But I want to tell you about an instrument which I think is the most sensitive instrument in the world for radioactive iodine in the atmosphere. I call it a biospectrometer, but it's really the thyroid gland of the grazing animals.
It's Saturday morning, and Dr. Lester VanMiddlesworth is heading for work. He's leaving his home in Midtown Memphis and riding his bicycle the 4 miles to his lab at the University of Tennessee Health Science Center in Memphis, Tennessee. Dr. Van has been cycling to his lab at UT since 1946. This is a fall day in 2007, and Dr. Van is 88 years old.
Hi. Good morning.
He continues to work 12 hours a day, 6 days a week, publishing new research, presenting seminars, and teaching students. Dubbed by his colleagues in the International Thyroid Association as the world's most enthusiastic scientist, Dr. Van's dedication and excitement for research, teaching, and clinical medicine continue to inspire everyone he meets each day. Any day of the year, students and faculty can get a boost of energy by visiting Dr. Van and his wife Rue in the lab at the Physiology Department at UT Memphis. This is Dr. Van's first lab in the basement of his childhood home in Alexandria, Virginia during the 1920s. After completing a dual master's degree in chemistry and physiology at University of Virginia in 1942, Dr. Van says this cloud of possibilities led him to a promised land full of excitement at the University of California, Berkeley, where he participated in the Manhattan Project as a physiology graduate student. His assignment was to study the metabolism of an unidentified element Z. It was ultimately declassified as plutonium. As a graduate student teaching assistant, Dr. Van became enthusiastic about teaching. One of his Berkeley professors suggested if he was interested in teaching in medical school, he should get a medical degree. He was penniless, so he wrote physiology departments all over the countries to find which one would permit him to pay his way through medical school by teaching physiology. In 1946, Dr. Paul Quigley accepted the opportunity and employed him to teach physiology to medical and dental students at the University of Tennessee, Memphis.
For most people, farm animals are important as a source of food or wool. But one researcher uses livestock as a record of nuclear fallout over the decades. The bomb. Scenes like these from the early 50s are powerful reminders of the past nuclear threat. Many of those blasts have been recorded by cameras. Dr. Lester VanMiddlesworth studies bomb recordings, but his aren't on film. He uses a University of Tennessee laboratory to study animal thyroids, tiny glands removed from the necks of cows and sheep. In 1954, he began testing livestock thyroids across the U.S. and found them all contaminated by radioactive iodine-131. At high levels, he could only link to fallout from ongoing nuclear bomb tests.
In 3 days, we had a good indication that the whole country was contaminated with radioiodine in measurable quantities. That was quite a surprise. No one would believe that at the time.
He's got plenty of believers today. Since the 1950s, volunteers in more than a dozen countries have been sending him thyroids to measure for radiation. Thyroids from different locations help indicate how wind currents scatter radiation around the world. Radioactive particles drift till they settle on Earth, often on the grass that livestock eat. The iodine concentrates in their thyroids because the gland needs iodine to produce growth hormone, and there's plenty of iodine in nuclear contamination. But animal thyroids accumulate a lot more iodine than humans would, for a very good reason.
The animals are 1,000 times more, accumulate more than 1,000 times more radioiodine than the human does. Why? I think it's because we don't eat as much grass as the animals do.
All that livestock data are recorded in scroll after scroll, each painting a unique biological picture of the nuclear age. The graphs trace nearly 40 years of animal thyroid tests. Every jump in radiation level corresponds to an above-ground bomb test. For example, levels of iodine-131 from a 1961 Siberian blast were equal in sheep thyroids from both England and Tennessee.
The animals in Tennessee and the animals in England went to exactly the same place, proving that the entire hemisphere was contaminated.
VanMiddlesworth says iodine-131 only has an 8-day half-life, meaning half of its radiation decays in 8 days, not long enough to harm animals or people. But its fingerprint shows up from more than bomb tests. In 1986, the accident at the Soviet Chernobyl nuclear reactor rained deadly radiation over nearby communities. With thyroid samples, fallout was mapped as far away as England. Chernobyl is the last time VanMiddlesworth's thyroid tests detected radiation. Now he's having trouble convincing the U.S. government to fund thyroid analysis because bomb tests are no longer above ground and the threat of nuclear contamination is low.
If you only wait until somebody says look for it, then it will take you maybe a week just to get things going. And that week is one half-life. That means it's down to half already. So you have to estimate what it was.
By taking baseline measurements in safer times, VanMiddlesworth says thyroid tests will provide timely biological records that could reveal any danger if a nuclear accident happens again.
So it became a very sensitive index, a whole lot less expensive than U-2 airplanes. And we just get it by sitting in the laboratory, waiting for the cows and the sheep to eat their grass, sit down and enjoy it, put the thyroid, iodine in the thyroid, go to the slaughterhouse, give us a thyroid, and the little old thyroid, which in the sheep is smaller than the end of your finger, but it has integrated the radioiodine from acres of ground. So it was a great indicator. And of course, this kept up. So all during the Cold War, we were, from 1954 on, we were getting these continuous monitoring of nuclear testing. Well, and the surprising thing, people all over the world started sending us thyroids, but these thyroids were all at no cost. I would determine the radioactivity in the thyroids, I'd send it back to the man who sent me the thyroid glands, and I'd tell him the amount of activity in his thyroids, and he would get so excited, he would go back to the slaughterhouse, send me more thyroids, and this was the only way we could keep getting thyroid glands. It had to be from people's curiosity. They themselves wanted to do it. It wasn't to be bought, it wasn't to be paid for, but when it became interesting to the people who would do it, you couldn't stop them, you couldn't turn them off. And so we got thyroid glands then, and they started coming continually. In fact, every week or two, we would get containers. We were, in 77, we were again monitoring these things, and I got a letter in the mail inviting me to come to the office of the president to discuss these data. And so I went up there, and at the executive office of the president in Washington, there was meeting. A lot of people were there, about 15 people, and they were all physicists. I couldn't understand what this was, and they asked me to come to present the data on the cattle. So I went into this office, this built room where the chairman of the National Academy of Science was in charge, and he sat me down and drew a picture of the table and showed me the names and the professions of all the people at the table and said, now you can tell them about it. And so I told them, gee, you know, there's no biologist here. But I want to tell you about an instrument which I think is the most sensitive instrument in the world for radioactive iodine in the atmosphere. I call it a biospectrometer, but it's really the thyroid gland of the grazing animals. And I'll show you how sensitive it is. And so we showed these graphs of the sensitivity monitoring with just by really through the milk of human kindness, people all over the world, just ordinary people, physicians, slaughterhouse men, college professors, people just working in the slaughterhouse, and physicists who would just send us thyroid glands because of their personal interest. And that was the way we kept it going.
It's the original observations written on there with a pencil. A 6-cycle log scale. And then up here is the committee where they're meeting to stop testing in the atmosphere. Yeah. Oh, yeah. This increase occurred before the newspaper release of this shot here. So that's saying the cows detected before the newspapers did. Yeah. Oh, that's the most exciting part of this.
Okay.
We finally measured 80,000 thyroids and never paid for one. How'd I get another one? I'd send him the data. And when he got the data, he couldn't stay away from the slaughterhouse.
We had to use semi-log-graph paper, and so we found that as we did this over a period of time, and if I were to then unfold it, it becomes a very long graph. That was 1956, 1957. In the summer of 1957, they really went very, very high. They went up to where, that's where I had to glue on more log scales to show a higher increase. Instead of just going up 100, 1,000 times, they went up 10, 100,000, 10,000, 100,000, a million, a million, a million. Yeah, having samples like that made at least the lab unique, because nobody else has a sample of a thyroid gland from a cow from 1963, except in our lab. And what's the importance of 63 to 93? Aha, the only way you can find that out is to have a 63 to measure. So we have it. Yeah, this is a radioautograph of the microscope section of a slide from Nigeria, West Africa, radioautograph that was exposed for 1 year and 2 months. When I tried to develop it, I couldn't do it. But still, I figured I'd someday learn to develop it. So I exposed them, began the exposure in 1978. Now, in 2005, I developed them, which is, I'll never live to repeat that experiment. Yeah, you just don't often do an experiment that you expect to finally develop and get the answer 27 years later. I don't know. The only example I know of is your great-grandchildren. They're your experiment that you are going to harvest in 27 years.
So my only interest was the thyroid, but I find the thyroid leads to everything. And so I think it's part of the integration of all nature. If you look deep enough and thoroughly enough and continuously enough at anything, you'll find it's all integrated together, so that there is no separation. Its separation is all in our own mind. There is no separation, it's all one. And if you take advantage of all the opportunities as they come, serendipity will take care of you.
I bet it will.